Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the HTTP host header attacks module titled Web Cache Poisoning via Ambiguous Requests. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs, and then do a search on host header attacks and select lab number 3 titled Web Cache Poisoning via Ambiguous Requests. Alright, let's get started. This lab is vulnerable to web cache poisoning due to discrepancies in how that cache and the backend application handle ambiguous requests. An unsuspecting user regularly visits the site's homepage. To solve the lab, poison the cache so the homepage executes this payload over here in the victim's browser. So the vulnerable parameter is likely to be the host header since we're working with the host header attacks module. And the goal over here is to perform a web cache poisoning attack that alerts on the victim's cookie. Let's click on terminal over here, or view and word wrap so that we could see the entire text. All right, so this is a web cache poisoning attack. We'll talk about that in a bit, but it's a really nice lab because it combines two different types of attacks. So the first one is web cache poisoning, and the second one is host header injection. And so when you chain these two attacks together, you're able to run malicious JavaScript in the victim's browser. All right, let's access the lab. Now notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I'm using the professional version of Burp Suite. However, all the features I'm going to use over here are available in the Community Edition, so feel free to use whichever version is available to you. Now, before we start the lab, we need to talk a little bit about web cache poisoning. Web cache poisoning is a technique where an attacker exploits the behavior of the application and its corresponding cache so that a harmful HTTP response is served to other users of the application. To better understand how that works, we need to understand how web caching works. So let's take an example. Imagine you have a user of the application. We'll just say user. You've got the cache. This is not the cache of the user's browser. This is the cache of the website or the web server itself. And then we've got the backend web server. Now, let's say user 1 requests the homepage of the application. So we'll represent that with an arrow. The way the application or the browser is going to treat that is it'll send a request to the backend server. The backend server will extract the code for the home page and then send it to the user's browser. And it's a bit hard to represent that in Visual Studio, but here we go. So when a user is requesting a page for the first time, let's say a home page, it's not cached. And so what happens is the browser sends a request to the web server. The web server loads the code for the home page and sends it to the user's browser. Now what happens when user 2 requests the same home page? So this is an unauthenticated home page, so the same code will be displayed to all users. Now what happens is because it was requested already by user 1, instead of going all the way to the web server to request the same home page, the application requests it from the application web cache. So this is the cached home page, and it sends it to the user's browser. And again, we'll represent that with an arrow. And this is essentially how web caching works. The reason websites implement this caching functionality is because if the server has to send a new response to every single HTTP request separately, it would likely overload the server and cause latency issues. And so websites use caching to avoid these issues. Now, if there are cache design or implementation flaws, an attacker can potentially exploit this vulnerability in order to deliver a malicious payload to other users of the application using the website cache. Now, there is an entire module on this topic in the Portswigger Web Security Academy that we haven't yet covered in our own academy as of the recording of this video, but we hope to cover it in the near future. So depending on when you're watching this video, the topic may or may not be covered. However, we will go over all the information that you need in terms of web cache poisoning in order to complete the lab. And really, you only need to understand the 3 steps that are used to construct a web cache poisoning attack. So let's write that down. So 3 steps to construct a web cache poisoning attack. The first step is to identify and evaluate unkeyed inputs. Unkeyed inputs are inputs that web caches ignore when deciding whether to serve a cached response to the user. These inputs are perfect for an attacker because the attacker can use them to inject their payload and elicit a poisoned response to the victim user. We'll talk more about that when we solve the lab, and it'll make more sense once you actually get hands-on experience in identifying these types of inputs. The second step is to elicit a harmful response from the backend server. So once you have an unkeyed input, you need to see if that input can be used to deliver your payload and exploit a vulnerable functionality in the application. For our case over here, we're going to use the host header as the unkeyed input in order to deliver our harmful payload. And then number 3 is to get the response cached. The whole point of this attack is to poison a cache that gets delivered to the victim that requests the same page where the malicious payload is stored. If you can't cache the page, this whole attack falls apart. So this step is really important. So if we look at our example over here, the whole idea is, let's say user 1 is actually the attacker. The whole idea over here is for attacker or user 1 to add a harmful input in one of the input parameters of the application. In this case, it's the host header, and then have it as a cached response. And so whenever user 2, user 3, user 4, or so on retrieve the same page, so the home page, they get the cached home page, which contains the malicious payload of the attacker. And so the malicious payload ends up running in their own browser and compromises those users. Again, we'll see how that works in the lab environment, and it'll likely make much more sense. So let's select the home page over here and see the request that is generated in Burp. So this is the request to the general home page. We're going to send that to repeater. And then in repeater over here, you could see that we've got a GET request to the home page. Now for this lab, we're going to assume that we already know that the host header is an unkeyed input, and we're just going to verify that it's truly an unkeyed input. But in a real world scenario or in a real pen test, what you're going to do is you're going to use automated tools or extensions in Burp where it tests every single parameter. So think of it as testing every single header over here in order to determine which headers are unkeyed inputs. And then based on that, you would have to individually test each header to see if you could inject a malicious payload in those that are determined to be unkeyed inputs. But for this lab over here, we're going to cut it short and we're going to assume that the host header is the one that we want to work with. So first, let's hit send, see the response in the application. Right away, you see that it's using caching headers, so I know that the application is caching responses. So the first thing I'm going to do is just change the host header to a random value. Let's say ranakhalil.com, which is my website. Hit send. And right away, I get a server error, which means that the application is accepting only a specific format of the host header. So it has some kind of backend validation. So let's go back. So this was the original host header. Now, another technique that we learned about in a previous lab for host header injection is to inject two host headers. Because sometimes if the application has some kind of flaw in the logic in the way it validates the host header, what it'll do is it'll consider both host headers. It'll validate the first one, but it won't validate the second one, although it's considered as a legitimate host header. And so in this case, we can bypass certain validation techniques by adding our own host header in the second host header parameter. So let's hit send and see if it works, and we get a 200 OK. So this is really good. That means that the application is accepting two host headers. But now the next step is to see if this host header is actually displayed anywhere in the response. So we're going to do a search on it, and perfect. So not only is the application accepting two host headers, it actually relies on the second host header in order to populate the client-side response right over here. So right away, I can tell this is an unkeyed input, but just to verify, we've got an input vector over here in the response that gets displayed. The value of the input vector gets displayed in the body of the request. And if we hit send over here, you could see Xcache header says miss. Now, miss means that it's not cached, or the cache may have not been invalidated or expired. And so I wonder if we hit send again, if we get a hit. And we do. Hit means that the page was already cached by the CDN or the proxy server, so it's coming from the cache of the web server instead of the web server itself. So if we look at the page over here, what we did is we included a request to the home page that contains two host headers. And the first time we had to retrieve it from the home page, but the second time we requested it, it came from the cached web server. And so right away, I can tell that this is where my exploit is going to be. It's going to be in the host header. Now, to confirm that this is truly cached, we could remove the host header and see if we still have ranakhalil.com in the response of the request. Hit send. And it's a miss. Interesting. So we might have to do this again. It's a little bit finicky. So hit send. We get a hit, but not on ranakhalil.com because it cached the previous one that we sent, not this one. So let's hit send again until it misses. And this is actually a really good point. So it looks like it is resetting. So it's a miss right now, but if we remove it, it should be a hit. Here we go. So now we no longer have ranakhalil.com in the host header. However, you could see it's still saved in the response of the request because it's actually serving the page from the previous request that we made from the cache of the web server. Okay, so this is really good. Now, one thing that is extremely important to mention is that when you're testing, you really need to use a cache buster. So before you start adding malicious payloads, it is really good practice that you have something called a cache buster in your request, especially if you're testing in a live system or a live environment. Because if you do attempt to perform an exploit in this request and it is successful, all the users that request this homepage over here will get exploited. So the exploit is going to run in their browsers when the page is served, and it's going to cause a huge issue if these are legitimate users and you're actually testing in a live environment. And so a good idea is to always use a cache buster. This could be any random parameter. So I'm just saying CB and I'm going to set it to any random number over here. So now whenever I perform an exploit, the exploit will only work on this specific URL, which I just set randomly. And so no users will get affected by this exploit. Once we confirm that our attack works, what we'll do is we'll remove this and we'll send our exploit to our main page because we do want the victim user who's accessing the main page to get exploited. All right, so let's test it out again. So we said ranakhalil.com and hit send. It should be a miss because now we're working with a different URL. And we're going to copy this and see where our host header payload is being injected. So It doesn't look like we properly copied. Let's copy it, paste it in here. And what this code is doing is it's essentially saying run this script, which is JavaScript. And the script is located in host header. So whatever the host of the application is, usually it would use the legitimate host over here, /resources/js/tracking.js. However, because this application is vulnerable to host header injection, we could inject whatever host header we want, and then it will be injected in the client-side code of the application. So the whole idea of this attack is to inject our own malicious host header. So the link to our own malicious web server. We're going to create this specific file in our web server. So /resources/js/tracking.js. And we're going to include our malicious JavaScript in this JavaScript file. And that's what we're going to do. So we're going to go to the exploit server. This is going to be the URL to our malicious website. And then we need to create this specific path and this specific file name. So tracking.js, and we're going to include our malicious JavaScript over here. To complete the lab, all we need to do is alert on the user's cookie. So we're going to say alert document.cookie. We're going to store it. And then if we view the exploit, you could see over here, it just simply our web server /resources/js/tracking.js. And this file, all it contains is the payload to display the cookie of the user. Okay, so we've got our payload. Now the next step is to simply inject our host header, so our malicious web server, into the website using the host header injection. So we're going to copy that. We're going to paste it in here. Hit send. First time it should say miss, but you could see over here now it's injecting our exploit server's URL, and it should run the JS script over here, so tracking.js, which should display the user's cookie. So if we try and access this URL in the browser, we should get alerted with the user's cookie. And this is why you use a cache buster, because if we were to do it on the home page and this is a live system and this is actually successful, you're going to exploit all the users that visit the home page. So hit send. And it does not look like we get displayed with a cookie. So let's just make sure it gets cached. And it looks like it didn't get properly cached because we don't see exploit over here. So let's send it again until it gets cached. So we're looking for miss. Here we go. One more time. It says hit. Now hit send. And here we go. Our payload was executed and we get alerted with the cookie of the user, which is an empty cookie, but the payload worked. All right, so now we know that the payload works on this specific URL. We're ready to deliver this to the victim user. So the victim user is going to access the homepage of the application. So we do have to deliver this exploit to the main homepage of the application. Hit send. It should be a miss first because the previous exploit was on a different URL. Hit send again. It's a hit. And now if we access the main page of the application, it should work. And right away you see it says, congratulations, you solved the lab. But if we hit send, it displays the alert box. All right, so we successfully completed the exercise by exploiting a host header injection vulnerability in order to perform a web cache poisoning attack. In the next lab, we'll look at another technique on how to perform a host header injection attack.